Next two reactions in this topic is oxidation. Oxidation, that means when acetaldehyde undergoes oxidation in the presence of HNO3, nothing but nitric acid, then we get which one? Acetic acid. Here you have to observe one point, that is what? Here aldehyde. This aldehyde having how many carbons? 2 carbons. This acid having how many carbons? 2 carbons here also. That means when aldehydes undergoes oxidation, then we get acids with the same number of carbon atoms. When aldehydes undergoes oxidation in the presence of oxygen, in the presence of HNO3, then we get acids with the same number of carbons. Here this is what? Ketone, nothing but acetone. When acetone undergoes oxidation, then we get less number of then we get acids with less number of carbon atoms. See here, this acid contains how many carbons? 2 carbons. This ketone having how many carbons? 1 2 3. Here we get 2 products. In 2 products, number of carbons are less compared to reactant. So what is the point here? When aldehydes undergoes oxidation, then we get acids with the same number of carbons. But in case of ketones, we get acids with less number of carbons. This part will become acid and this part will become which one? This part will become formic acid. I will show one example regarding this one. See, suppose when we take this compound C6H5 C double bond O CH3 oxidation, then we get which one? Oxidation in the presence of H4, then we get C6H5 COOH plus HCOH. Suppose if you take this one C2H5 C double bond O CH3 oxidation, then we get which one? C2H5 COOH plus HCOH. Here you should not see that the reaction is not balanced. Here balancing the reaction is not mandatory. Which is the main thing here? When ketones undergoes oxidation, then we get acids with less number of carbons. That is the point only here. Next point, reduction. See, when acetaldehyde undergoes reduction in the presence of LiAlH4, nothing but lithium aluminum hydride, then we get CH3 CH2OH. This is what? Ethyl alcohol. When acetaldehyde undergoes reduction in the presence of LiAlH4, then we get ethyl alcohol. That means what happens? This CHO becomes CH2OH. That means 2 hydrogens added at a carbonyl carbon. I will show that reaction here. CH3CHO, it can be written as CH3 C double bond OH. When it undergoes reduction in the presence of LiAlH4, what happens? One hydrogen is going to attack here, one hydrogen is going to attack here, then we get CH3 CHOOH. That means CH3 CH2OH. That's it. That means CHO becomes which one? CH2OH. But in case of ketones, when acetone undergoes reduction in the presence of LiAlH4, when acetone undergoes reduction in the presence of LiAlH4, what happens? This C double bond O becomes CHOH. CHOH. That means secondary alcohol. So what is the point here? When aldehyde undergoes reduction, then we get primary alcohol. This is primary alcohol. When ketones undergoes reduction, then we get secondary alcohol. In case of aldehydes, we get primary alcohols. In case of ketones, we get secondary alcohol. This is about oxidation and reactions of aldehydes and ketones. I will show some examples here. See, when this compound reacts with the LiAlH4, what happens? What is the product? Here one hydrogen is going to attack, here one hydrogen is going to attack, then C double bond O become CHOH. Here CH is present, CHOH. That's it. You may get these type of questions in exams. Next reaction is Clemenson's reaction. Clemenson's. There is also called Clemenson's reduction, because this is also one of the reduction reaction. See, when acetaldehyde or any aldehyde undergoes reduction in the presence of zinc amalgam and concentrated HCl, that means in Clemenson's reduction, this is a reducing agent. When any aldehyde undergoes reduction in the presence of Clemenson's reduction, then what happen? C double bond O becomes CH2. C double bond O becomes CH2. That means CH3. C here C double bond becomes CH2. That means CH2H again CH3. That means alkanes are formed. So what is the significance of Clemenson's reduction? C double bond O becomes CH2. Here see, when acetone undergoes reduction in the presence of same reagent, here also C double bond O becomes CH2. That means reduction. So what is the point here? When aldehyde or ketone undergoes reduction in the presence of zinc amalgam and concentrated HCl, then you get alkanes. This is called one of the important named reaction, Clemenson's reduction. This is very, very important named reaction. Next one, Wolff-Kishner reduction. Wolff-Kishner reduction means when aldehydes, here also reduction, undergoes reduction in the presence of hydrazine and ethylene glycol. When aldehydes undergoes reduction in the presence of hydrazine and ethylene glycol, that is called Wolff-Kishner reduction. So what is the product here? What is the reactant? CH3CHO is the reactant. Here product is CH3CH3. This is reactant. CH3CHO is the reactant. CH3CH3 is the product. That means here also which mechanism takes place? What is the point here? C double bond O becomes CH2 here also. Initially this compound reacts with NH2. That means condensation takes place. That means this O and H2 removed. Then this is the compound CH3, CH double bond N and H2. This is what is acetaldehyd hydrazone. When this compound treated with KOH in the presence of ethylene glycol, then this part will be removed. Which part? This nitrogen will be removed. Then CH3 will be formed. So finally C double bond O converted into CH2. Here also see, when acetone reacts with hydrogen, what happens? CH3, C, this CH3 here, I wrote here, double bond N, NH2. When this compound treated with KOH in the presence of ethylene glycol, then what happens? This N2 will be removed. Finally we get which one? CH3, CH2, this H2, CH3. That means this C double bond was converted into CH2. N2 is the byproduct. So this is also one of the named reaction. Which one? Wolff-Kishner reaction. Here also what is the phenomenon takes place? Here also C double bond was converted into CH2 group. So in Clemenson's reduction and Wolff-Kishner reduction, in both reductions, both are named reactions, both are reduction reactions. In both reactions, C double bond O is converted into CH2 group. This is very, very important point. Both are named reactions, you have to remember. I will show one more example regarding this one. See, when this compound, that means same compound, reacts with LiAlH4, which one? This we get this one. Suppose when this compound treated with zinc amalgam concentrated HCl, that means Clemenson's reduction. This is normal reduction. Then what happened? This C double bond was converted into CH2. That means cyclohexane will be formed. This oxygen is removed by 2 hydrogens. We have to catch the difference between these two reactions. This is reduction reaction. This is also reduction. But here reducing agent is LiLH4. Here what happens? C double bond O becomes CHOH. But here reducing agent is what? Zinc amalgam and concentrated HCl. Here what is the mechanism takes place? C double bond O converted into CH2 group. So both are reduction, but phenomena are different. You have to remember those points. This is about reduction reactions in aldehydes and ketones. There are some more reactions in aldehydes and ketones. I will discuss those reactions in next class. Thank you.